So let's continue with the method of variation of parameters. I would like to solve here a couple of examples. So the first one, let's consider the problem y double prime minus y, and it is equal to 1 over x. So homo, it's a non-homogeneous second order linear differential equations, and we are lucky that the coefficients of y double prime and y, they are constants. So we can write the homogeneous part. So let's write what we are looking for. We are looking for the homogeneous solution and the particular solution. This problem cannot be solved by the method of undetermined coefficients because the f of x, which is the function input to the system, is not one of those functions from which we can construct the particular solution by using the principle of superposition and principle of original homogeneity. So we have to look for the method of variation of parameters. So we first require the homogeneous part so that we can write y1 of x and y2 of x. So we have to construct the auxiliary equation. So the auxiliary equation, for the differential equation, it is uh, lambda squared minus lambda, and it is equal to 0, not lambda. Lambda squared minus 1 equal to 0, and we can then factorize it as lambda plus 1 and lambda minus 1 equal to 0. So with the values of lambda minus 1 and lambda equal to 1, uh, we can write the homogeneous solution of x, and it is equal to c1 e raised to the power minus 1 x. This is the first lambda value, and c2 e raised to the power plus 1x. So this is the homogeneous part, and they are linearly independent. So we can construct yp. It will be equal to u1 y1 plus u2 y2, and we know we have to consider the system of equations we developed in the previous lecture. So these are the expressions. So for a 2 by 2 system, second order differential equation, we come across these equations with our assumption as u1 prime y1 plus u2 prime y2 equal to 0. This is the first equation, and the second equation, u1 prime y1 prime plus u2 prime y2 prime equal to f of x over a of x. And it leads to the generation of Wronskian determinant, which is an expression that y2 and y1 are independent, linearly independent, and then we can evaluate the integral uh, to get the value of u1, and similarly for u2. So let's implement that to have confidence in the approach. Okay. So I write here the Wronskian determinant. So it is y1, which is e raised to the power minus x. It is e raised to the power x, and its derivative will be minus 1 e raised to the power minus x, and the derivative of this one will be e raised to the power x. So then it is e raised to the power minus x, e raised to the power x, and plus e raised to the power x and e raised to the power minus x. So it is equal to 2. So non-singular matrix, indication of non-singular matrix. So we can proceed for u1. So u1 is equal to the integral. So minus y2, which is ex, and times f of x. Our f of x is 1 over x, and then divided by the Wronskian, which is 2. So this is correct. Minus y2. Yeah. So we have to integrate it with respect to x. So 1 by 2 e raised to the power minus x, and this is over x dx. So this integral cannot be solved analytically. So we will keep that one as such while writing the solution. So similarly for u2, it will be equal to, okay, let's write the expression. u2 is y1 of x times f of x over a of x. That's what we developed, and u n dx. Okay. So Wronskian is 2 y1 of x. Okay. Y1 of x was considered to be e raised to power minus x. Okay, while writing over here, I found that there is a mistake. So yes, there will be the minus. Okay, and from here, we will have y1 of x, then f of x is 1 over x, a of x is 1. So that's it. And this cannot be solved analytically. So I can write the final solution. So y of x with the homogeneous part c1 e raised to the power minus x plus c2 e raised to the power plus x plus y1 of x is e raised to the power minus x times the integral with 1 by 2 minus e raised to the power x over x dx, and plus the other part y2 of x times u2 of x. So 1 by 2 integral e raised to the power minus x over x dx. So this requires the numerical methods to be called for to get the numerical values. Analytically, we cannot proceed further. So let's attempt another example. So the other example. Okay. Example 2. So y double prime minus 4y plus 4y, and it is equal to x plus 1 and e raised to the power 2x. Okay. So this is the equation, second order linear with constant coefficients. So again, we will start with the auxiliary equation. So if we construct the auxiliary equation, it is lambda squared minus 4 lambda and plus 4, it is equal to 0. So we have to construct the solutions by using the quadratic equation. So 4 plus minus, then 16 minus 4ab. So it is 4 times, and this is 2. So we end up with the equal roots equal to 2. So for this one, we can write the homogeneous solution. So it will be C1 e raised to the power 2x and plus the other part C2 times x and e raised to the power 2x. That is due to uh, the method that was developed similar to the method of variation of parameters. So this is the homogeneous part, and this problem is interesting. It can be solved by the method of undetermined coefficient, because in the uh, input function f of x is a product of a polynomial and the exponential function. So for which we can write the solution on the basis of the inspection, with the one condition that the proposed solution have no term similar to the homogeneous part. So it is going to be proportional to that one. So that's the beauty of the author, Professor Dennis Zill, that he provides a problem that can be solved by another method so that you can compare. So this can be solved by the method of undetermined coefficient. Undetermined coefficient. Of undetermined coefficient. So anyway, if we proceed for the method of Wronskian method, so we have to first check the independence of the two. So by the way, we require only the evaluation of Wronskian determinant. So y1 is e raised to the power 2x and y2 is x e to the power 2x. So their derivatives, y prime is e raised to the power 2x times 2, and y1 prime, this is y2 prime will be, okay, it requires the product rule. So x e raised to the power 2x times 2. So here, and then x differentiated to 1, and this is e raised to the power 2x. Okay, now the evaluation of Wronskian, so it is e raised to the power 2x, x e to the power 2x, and then it is 2 e raised to the power 2x, and this is e raised to the power 2x plus 2x e raised to the power 2x. Okay, and then again uh, uh, a calculation that requires a bit of patience. So e raised to the power 2x and e raised to the power 2x. So e raised to the power 4x plus 2x e raised to the power 4x, and minus 2 and x and e raised to the power 4x. Oh, this is a bit good news. Our expression has been simplified, and it is non-singular, so we can proceed. So again, write u1 of x, it will come from the integral minus y2 times f of x over a of x, and divided by the Wronskian determinant and dx. Okay, so y2 was x e raised to the power 2x, and f of x, okay, f of x was x plus 1 e raised to the power 2x, and Wronskian is e raised to the power 4x. So, okay. So it seems we are lucky to have another simplification. So the powers uh, are going to be, well, the e raised to the power, e raised to the power 2x and 2x and 4x, they are going to be eliminated from the expression. So we have rather a simple expression, which is x squared plus x and integral of that. So, so it will be minus x cubed by 3 plus x squared by 2. So this is u1 and u2 of x will be, so y1 of x, f of x over a of x, and divided by Wronskian dx, and it is equal to, okay, y1 of x was equal to e raised to the power 2x, and f of x is x plus 1 e raised to the power 2x, and a was equal to 1, and the Wronskian was e raised to the power 4x. So again, these powers will be simplified, and the integral will be evaluated to x squared by 2 plus x. So this is u2 of x. So we are ready to write the complete solution. So y of x will be c1, the homogeneous part was e raised to the power 2x, plus c2x e raised to the power 2x, plus the particular integral. So, okay. So u1 of x is, okay. Okay, I found here that it must be negative. So x cubed by 3 and x squared by 2. So I write here minus x cubed by 3 minus x squared by 2 times y1. So u1 by 1, so e raised to the power 2x, and plus x squared by 2 plus x, which is the u2, and y2 is x e raised to the power 2x. So we can collect the terms, and we can find that the terms are going to contain x cube and x squared, and also from here x cube and x squared. And if uh, you work out the calculation by using the method of undetermined coefficients, so you will recognize that if you start with the particular solution which is similar to f of x, so it was x plus 1 times e raised to the power 2x. So, of course, we have to have the constants like general constant ax plus b. However, with these constants, we find that b times e raised to the power 2x, we have the term available in the homogeneous part. And also, if we look for the other one, so x times e raised to the power 2x, this is also available over here. So we have to have x squared over here so that the terms become different from the terms of the homogeneous part. So we have to start with the with a high degree polynomial, we have to start with this one to come up with the solution from the method of undetermined coefficient. And you can see here the solution contains x cube times e raised to power 2x and x squared times e raised to power 2x. So whenever you have two or more methods to solve a problem, then it really becomes a matter of choice. Uh, and choice comes from, of course, the effort required to implement that method, and also the chances of falling into the errors. So it then becomes the matter of choice. So these are the examples of method of variation of parameters, which is primarily for which is of course for the equations in which the the equations are linear uh, differential equations, of course, of non-homogeneous type, and the function which is on the right hand side of the equation is not the the simple function, uh, which cannot be accommodated by the undetermined coefficient method. So with this, I hope that the students can attempt confidently the method of variation of parameters. So let's stop at this point. So do practice and learn.